Welcome back to Office Hours with Dr. Clark. Today we are going to be looking at metathesis reactions. So this is a topic in Gen Chem that really throws a lot of students because you have to balance equations and then disassociate them into ions. So recall that when an ionic compound is dissolved in water, it's not this anymore, like sodium chloride. It's actually, that's how we write it, it's Na plus AQ plus Cl minus AQ, right? So when you dissolve some salt in water, you have ions, right? Now let's look at calcium chloride. This is where it gets tricky. You dissolve that in water. Actually, it's Ca2 plus AQ. And how do we write this chloride? Because there are two chlorides. So write it 2Cl minus. You see, not Cl2 negative. That is very wrong. Okay. Likewise, what if we have Na2CO3, sodium carbonate? Dissolve that in water. That becomes 2Na plus and the carbonates. You see the difference? So now, metathesis reactions, there are four of them that you look at. There is solid forming, precipitation, SaCO, a cloudiness that's formed, or some, pretty color like yellow that's formed. There is gas forming, bubbles or effervescence. This is what we like to see in chemistry lab, things bubbling up and flowing out of test tubes, which you don't see in actual academic labs because we don't want anybody to get hurt. Water forming, neutralization. That's an acid-base reaction. And then there is, actually, there's only three of these. There's three: solid forming, gas forming, and water forming. So the water forming is also heat releasing. That's one way you can tell that that's happening because when these reactions happen, the water forming one, you don't see anything visibly happen. You see two clear solutions, generally clear solutions of an acid and a base. They mix, but it gets warm. So as you can tell, the reaction is going on. The other two are more evident. So let's look at that's one, two, three. Let's look at our solid form. So we're gonna mix sodium nitrates. Let's not do that one. Calcium nitrates and sodium carbonates. So these are two soluble compounds because all sodium compounds are generally soluble and all nitrates are generally soluble. So generally for these types of questions, you'll be given a solubility rule where you can see which is soluble, which is not. Really important. We don't expect you to remember all those. If you do it enough, you remember a lot of the rules. So what are the potential products? Will a reaction actually happen? So what we do is we say, all right, well, we're gonna swap partners. The calcium's gonna get the carbonate, and sodium's gonna get a nitrate. And we're gonna judge and see if either of these are insoluble. If that's the case, I should get a reaction. I should get a product and some kind of solid forming when I mix them. So sodium compounds and nitrates are always soluble. So this is AQ. What about calcium? So our rules tell us that calcium carbonate is actually one of those insoluble compounds. So that's going to be an S. And so a reaction will happen. You'll see a cloudiness. Calcium carbonate is saying we use a blackboard chalk, limestone. You find it in limestone and also in like Tums antacid. So now that we established that our reaction does happen, we need to we need to balance the equation. So, so let's see. So put two here. So we did talk about balance equation in early videos, so we're going to spend a lot of time on that. So this should be AQ. That means it's dissolved in aqueous solution, meaning water. So I'm going to break this down to ions. It's going to be Ca2 plus AQ plus 2 NO3 minus AQ plus 2 Na plus AQ plus CO3 2 minus AQ. So you see how I did that? So my calcium becomes Ca2 plus. Nitrates is 2 NO3 negative because it's two nitrates, two sodiums, one carbonate. That goes to 2 sodium plus 2. So this coefficient here, I have to include the coefficient because it's 2 sodium and 2 nitrates. And then calcium carbonate is insoluble, so it's not going to dissociate. So I leave it. So this is my total ionic equation. So I gotta find out what are my spectator ions. So essentially, what are the species that look the same on both sides? So I see the sodium appears unchanged, and likewise the nitrates. So those are what we call spectators. I mean, they're not really participating in the reaction. But the ones that do, I write down here, it's a calcium and a carbon. They find each other and they form a precipitate, calcium carbon. This is my net ionic equation. So that's one example. Let's look at the gas form. Let's take HCl. So if I have an acid and it's reacting with a carbonate, let's take potassium carbonate. It's going to form some bubbles, and these bubbles, so there's water that's formed. Carbon dioxide is what causes the bubbles, and some salts. So the salt is going to be the combination of the cation and the anion. It's going to be case, yeah, it's case. Make sure it's balanced. I think I'm all good. Yep. So now it's going to do the same thing. So HCl is going to break down to 2H plus AQ plus Cl minus AQ. And it should be 2, right? Put the 2's out here. Plus 2K plus AQ plus CO3 2 minus AQ. Water is a liquid, so water does not ionize. Carbon dioxide is a gas, so that doesn't ionize either. And but potassium chloride is water soluble and it will ionize. Remember, all group 1 elements are going to be water soluble. All group 1 elements, all ammonium, and then acetates and nitrates, those are generally soluble in water. So now I need to find my spectator. So I'm going left to right. So what are the ones that are that look the same? Chloride. Chloride looks the same. the change, likewise potassium. So then now my net ionic equation is just the species that are involved in the action. 2H plus, 2 gives me H2O liquid plus CO2 gas. That's the big deal for the equation. Okay. So that's our gas form. So acids and carbonates, and even acids and bicarbonates, will always react to get carbon dioxide and water. So if you have a little upset tummy, you swallow some baking soda, it's a similar type of action. You get the bubbly, the burpees, and that's carbon dioxide. That's occurring from neutralizing the acid. So something I didn't say in the beginning, these reactions called double replacements. Another name for them, double replacements. Because we're swapping partners. This one doesn't look like partners are being swapped, but it kind of essentially does because H and H and the H and the CO3 actually combines to give carbonic acid if we're being really specific, but then that breaks down very easily to H2O and CO2. So that's why we don't even write the carbonic acid. Because it will be a true swap. It will be KCl and carbonic acid, but the carbonic acid immediately breaks down to H2 and CO2. So that's why we just write that. Just want to give you some greater context. Last one on water forming neutralization. So let's take nitric acid. I like to use polyatomics in these examples because students are always afraid of polyatomics because, oh, I gotta memorize all these charges and these names. There's a lot. And it's college, it's chemistry. It's a lot, but it's worth it, and you can do it. All right. So nitric acid, and let's take calcium hydroxide. Just use calcium hydroxide to whitewash fences back in the olden days. Just call it lime water because when it reacted with the carbon dioxide atmosphere, produced calcium carbonate, which is limestone. A little historical stuff for you. It doesn't matter in the grand scheme of life. So acid and hydroxide will neutralize each other to form. We're swapping partners. Calcium grabs the nitrates. The H grabs the OH. So it's going to form the salt and water. Water is a liquid. This is soluble. So we have to worry about solubility rules when we're dealing with gas forming or acid-base neutralization reaction because they're always going to react. But what we have to figure out is how to write the ionic equations. So let's start. So nitric acid breaks down. Well, actually, let's balance it first because I'm thinking this needs to be balanced. Yeah, so should put a 2 there. And I think let's see, we got 2 there. We should be good. Yes. Plus AQ plus 2 NO3 negative AQ plus Ca2 plus AQ plus 2 hydroxide AQ gives me CO2 plus AQ plus 2 nitrates. You balance it properly when you're doing your ionic equations, and you're seeing the right amount of ions on both sides. That this balance. You didn't balance it when you're seeing like 1 nitrate and 2 nitrate on the other side. So we always have to be mindful. Remember, water is a liquid that does not get dissociated. So now we're looking left to right. What are our spectators? Clearly the calcium and the nitrates. So we circle. Oh, I do the circle while you're moving, right? Circle. So then now my net ionic is 2H plus AQ plus 2OH minus AQ to yield 2H2O. So that's why we call it water forming. That's the big deal. And this is our metathesis or double replacement reaction. Right. Until next time, Officer Ours is Dr. Clark.